Research methods, data analysis. Descriptive statistics. There is two key terminology for descriptive statistics. Firstly, there is measures of dispersion, which is broken down into standard deviation and range. The range is the difference between the largest number on your data and the smallest number on your data. Standard deviation is a quantity expressed in how much the members of a group differ from the mean of the value of the group for the group, which is a Google definition. Secondly, there is a measure of central tendency. This is broken down into mode, median, and mean. The mode is the most common value in a set of data. The mean is the average when the data is added up and divided by the number of values within the data, and the median is the middle value where the data is put into numerical order and the middle value is identified. Skewness. Skewness is how deep a curve is, and this diagram shows positive, negative, and neutral skewness. Positive being where it's more, the peak of the curve is more to the left, neutral where it's completely in the middle, and negative skewness being where the middle of the curve is more to the right. Kurtosis. Kurtosis shows the height or flatness of a curve. Positive kurtosis is where the curve is high and doesn't have much where it's flat, so the peak is narrow and the curve is high, whereas negative kurtosis is where there is a longer flat section and the curve is lower and more flat across the top. Inferential statistics. Inferential statistics test for relationships or differences within data. The point of inferential statistics is used to show data is not a fluke. For data to be proven, it is not down to chance and is significant. It needs to be equal or below 0.05. Parametric versus non-parametric data. Parametric data and non-parametric data are two types of inferential. Parametric and non-parametric. Parametric and non-parametric are two types of inferential tests. Parametric tests are for ratio and interval data. Ratio data is data with no negative value below 0. An example of ratio data is someone's weight, as it can't be below 0. Ratio is where data has gaps or intervals between, which are the same between each value. For example, the temperature scales at interval because each gap between 1 to 2, 2 to 3 degrees, and 4 is the same gap between. Non-parametric tests are used for ordinal and nominal data. Ordinal data is where data is ranked third, so third is better than fourth but worse than second. An example could be a leaderboard in sport. For example, in a competition, say a golf competition, first place is better than second, second place is better than third, third is better than fourth, and so on. Nominal data is where data is labelled but the scales don't overlap. For example, data is sectioned off by creating two labels such as male and female, and the data fits into one or the other. Pearson's product momentum correlation coefficient. Pearson's test is a parametric test that tests for relationships. It looks through the strengths of the relationships between the two variables of data. As you can see, there's positive correlation, where the data goes along the axis positively up towards the right. There's negative data where it heads downwards, so it's heading down towards, so there's a negative correlation, and no correlation is where there isn't a pattern of where the data follows along the two axes. Spearman's rank order correlation. Spearman's test is the non-parametric version of Pearson, so therefore it also tests relationships between data. It's used for ordinal or nominal data. There's monotonic, which is similar to negative Pearson's, where it heads down towards, whereas monotonic goes up. So the data that meets on the axis heads up towards the top corner rather than down. And non-monotonic is again where there's no relation, so it's not heading in a single direction. Mann-Whitney U. Mann-Whitney U is a non-parametric version of the independent t-test, meaning it is used for ordinal and nominal data. The level of significance is found from the test by the U-value it produces. The U-value decides the significance of the data. For the test to work, the data needs to be in two separate samples of similar data size. The test finds out the significance of two independent groups. This test requires ranked or normally distributed data for it to work. Finally, the t-test. The t-test tests for differences between two sets of data. For the t-test to be right, for the t-test to be right, the right test to use, the data must have similar variation to other data being used. During the t-test, the mean of the two data sets is analysed. There is two types of t-tests, independent and dependent. Independent t-tests tests two different groups completing the task or the same task group completing different tasks, whereas dependent tests the same group doing the same task twice.